Hey everyone! Today we've got some fascinating news about two of the most intriguing moons in our solar system, Europa, orbiting Jupiter, and Enceladus, orbiting Saturn. Both of these moons have oceans beneath their icy crusts, and new research from NASA suggests these hidden oceans could potentially harbor life. So, what's the scoop? A recent NASA experiment indicates that if there's life in these subsurface oceans, we might be able to detect it just below the surface ice. Scientists discovered that organic molecules, like amino acids and nucleic acids, could survive near the surface despite the intense radiation that bombards these moons. This means that future robotic missions wouldn't need to dig very deep to find signs of life. Alexander Pavlov, from NASA's Goddard Space Flight Center, explains, based on our experiments, the safe sampling depth for amino acids on Europa is almost 8 inches, around 20 centimeters, in areas where the surface hasn't been disturbed much by meteorite impacts. For Enceladus, the situation is even better. Amino acids could survive just 1/10 of an inch below the surface. These moons are harsh environments, with surfaces bombarded by radiation from their host planets and deep space. Yet, under their icy shells, Europa and Enceladus have oceans warmed by the gravitational forces of their parent planets and neighboring moons. If these oceans contain the right ingredients, they could potentially support life. The research team conducted experiments by mixing amino acids with ice and bombarding them with gamma rays to simulate the conditions on these moons. They found that amino acids can survive in the ice, especially when coming from microorganisms. This is crucial because amino acids are the building blocks of proteins, which are essential for life. Interestingly, the team found that amino acids degrade faster when mixed with dust, but survive longer when embedded in biological material. This means future missions looking for life should consider these factors when selecting sampling sites. Pavlov added, "Our results indicate that potential organic biomolecules degrade faster in silica-rich regions on both Europa and Enceladus compared to pure ice. So, future missions should be cautious about sampling in these areas." This research brings us one step closer to understanding the potential for life on these distant moons. Imagine the excitement of finding signs of life on Europa or Enceladus. It's discoveries like these that keep us exploring the cosmos. Stay tuned for more updates, and don't forget to subscribe for the latest space news and discoveries.